Hello everyone. In this video we're going to be solving a Diophantine equation. In other words, an equation with integer solutions. So we have x times x plus 2 times x plus 8 equals 3 to the power y. X and y are integers. So by multiplying three things we're getting a power of 3. So each of these factors must be a power of 3 because 3 is a prime number and y is an integer. So we can assume that x is something like 3 to the power a, this is something like 3 to the power b, and this is something like 3 to the power c. When we multiply all of these things, we get 3 to the power a times 3 to the power b times 3 to the power c, and that should equal 3 to the power y. When you multiply powers with the same base, you add the exponents, so the left-hand side gives us 3 to the power a plus b plus c, and the right-hand side stays the same. Now, since the bases are equal, they're both 3, and we know it, exponents must be equal, so a plus b plus c equals y. Okay, great. Now, we're going to need more equations, obviously. We're going to need more relations to be able to solve because we have 3 variables, maybe 4 variables in this case, a, b, c, and y. But we have our original equation. Notice that x and x plus 2 differ by 2. So they're kind of like consecutive odd numbers or consecutive even numbers. You can kind of decide which one is which, but let me not tell you what it is right now. So you can basically write, since 3 to the power b is x plus 2, and 3 to the power a is x, which is 2 less than that, their difference is going to be a 2. Now, this is something that I can factor. Now, in this case, since the difference is positive, I can safely say that b is greater than a, right? That is obvious, hopefully. So I can take out a smaller power, which is 3 to the power a, and inside the parentheses, so I'm kind of factoring out 3 to the power a, I get 3 to the power b minus a. To get 3 to the power b by multiplying by 3 to the power a, I do need 3 to the power b minus a, minus 1. So since b is greater than a, b minus a is positive, so this looks good. And this is equal to 2. Great. Now we're going to get a similar equation by using x and x plus 8. So let's see what happens. If I subtract 3 to the power c and 3 to the power a, we're going to get the difference between x plus 8 and x, which is 8. So this difference is equal to 8. So from here, we're going to do something similar. Take out 3 to the power a, which is the smaller power. And inside the parentheses, we get 3 to the power c minus a, so that when we multiply, it becomes 3 to the power c minus 1. And that equals 8. Great. Now notice that we're multiplying a power of 3 by something else, and we're getting 2. Is that possible? Okay, let me think about it. 3 times 2/3 is 2. Great, but 2/3 is not going to equal what's inside the parentheses because that's an integer, right? And b are integers. I mean, 3 to the power something is an integer in this case, so on and so forth. So 3 to the power 8 times something cannot equal to 2. So what's going to happen? Let's look at the second equation. 3 to the power 8 times something else is equal to 8 this time. That's also weird. This is not possible unless the power of 3 equals 1, because that's the only power of 3 that divides 2 and 8. So yes, that's right. A equals 0. That's a must. But when a equals 0, a lot of good things happen because you can just plug it in and find the other values. For example, from the first equation, this one, you get 3 to the power b minus 3 to the power 0, which is 1, equals 2. This means 3 to the power b equals 3, which means b equals 1. Great. We got the value of b as well. Is that the only value? Looks like it. Let's go ahead and take a look at another scenario. Well, how can I find the c, I mean? Not the scenario, but more like finding the value of c. Similarly, I can do the same thing. So like 3 to the power c minus 3 to the power 0 from here, which is 1, equals 8. 3 to the power c equals 9, and c equals 2. Obviously, if we got something like 3 to the power c equals 8, it wouldn't work, then there would be no integer solutions. But we do have some solutions. But remember, our goal is not to solve for a, b, and c. Our goal is to find x and y. So what is going on here? Okay, let's go back and back substitute. we assumed at the very beginning that x is equal to 3 to the power a. Great. So since a is equal to 0 and x is equal to 3 to the power a, this implies that x is equal to 1. Awesome. What about the y value? Well, we said that y is equal to a plus b plus c here, remember? So if I have the values of a, b, and c, which I do have here, I can just add them up and find the y value. So the y value is going to be 0 plus 1 plus 2, and that is going to be a 3. So it looks like the only solution to this equation is 1 comma 3. So x must be 1 and y must be a 3. Let's go ahead and check it out in our original problem. Our original problem was x times x plus 2 times x plus 8 equals 3 to the power y. Now if x is equal to 1, then we're multiplying 1 times 3 times 1 plus 8, which is 9. And that is equal to 27. And obviously 27 is equal to 3 to the third power. Therefore, our solution is valid. So this brings us to the end of this video. Well, thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.